Hi, my name is Brian Schoepfle, and I manage a global team of solution architects at AWS Worldwide Public Sector. I'm delighted to join DLT Solutions, a tech data company, for a discussion around a key theme that is emerging for public sector organizations. It's one that's driving some exciting innovation in the cloud, and that is the importance of understanding the power of data as a strategic asset. Virtually every organization is in active evaluations to modernize their data platform, and many have an executive level mandate to be data-driven. The reason? Effective leaders rely on data to make informed decisions, look around corners, and take meaningful action. They want to build a modern data strategy to deliver insights to the people and applications that need it, securely and at any scale. To do this, they know they need to build a better data foundation to modernize their data infrastructure, unify the best of both data lakes and purpose-built data stores, and innovate new experiences and reimagine old processes with artificial intelligence and machine learning. Public sector IT leaders can all agree on the mission-critical nature of their data, and they know they need to leverage that data to drive innovation and unlock insights they wouldn't be able to access with legacy systems, all while keeping costs low. The Harvard Business Review recognized that data strategy is the central determinant of a successful organizational strategy. But many public sector organizations often have outmoded tools, aging infrastructure, and inefficient methods for collecting and analyzing the data they already have. That's to say nothing of the continuously expanding types, sizes, and sources of data they can collect. Just how important is data strategy to the organization strategy? The security information and event management company Splunk conducted a survey of 1,300 executives and found that, on average, executives believe about 55% of their organization's data is dark. What is dark data? Well, dark data is all of that information constantly being generated, collected, processed, and stored in your environment, but never used again for any other purpose. Perhaps it's being retained for compliance purposes or for some other reason, but it's generally not used or even accessible for understanding complex relationships between the data, extracting insights, or making educated predictions about the future. All activities that enable organizations to support the communities and constituents they serve. Just 12% of those surveyed are using artificial intelligence to achieve these tasks today, with another 2/3 planning on using AI in the next 5 years. What's holding them back? They said the major impediment to implementing AI is understanding their own data. Artificial intelligence and machine learning are being used by public sector organizations like the U.S. Department of Veterans Affairs to track and analyze COVID-19 outbreak areas and make timely decisions using supply chain, hospital inventory, and social services data. Or the City of Los Angeles performing real-time analysis of 240 million security records daily from 40 different agencies, protecting the city from over 100 million cybersecurity threat attempts. The oldest national nonprofit conservation organization in the United States, American Forests, is using machine learning on AWS to centrally analyze geospatial data from more than 25 nationwide datasets to support their goal of planting over 500 million trees in the cities and communities that need green spaces the most. Cooling air temperatures at street level by as many as 10 degrees, absorbing air pollutants, and preventing almost 700,000 incidents of respiratory illness per year. What's common to all these incredible projects? The data. AI and ML need to act upon data to generate insights, so the data strategy must come first. To achieve their missions, organizations need to build a modern data strategy that will grow with them in the future. The ideal data strategy is not one size fits all, it's adapted for your needs. It gives you the best of both data lakes and purpose-built data stores. It lets you store any amount of data you need at a low cost and in open, standards-based data formats. It isn't restricted by data silos and lets you empower people to run analytics or machine learning using their preferred tool or technique. Of course, it also lets you securely manage who has access to the data. With the cloud's ability to make formerly separated and siloed data available to analysis tools, organizations can now more easily analyze their data to gain insights in a variety of different ways. Public sector organizations are adopting a data strategy model that takes into account the business strategy, the people and culture of the organization, the need to drive value, and in some cases, monetization of the data, the nature of the data itself, and it ties all of that back to the actions, decisions, and business questions that will be informed by higher quality data and innovative analytical models. Unquestionably, one solution area that is making cloud-hosted data even more important is IoT, the Internet of Things. Smart cities, smart ports, smart campuses, smart bases, all driven by connected controllers, sensors, and other telemetry devices, generating enormous amounts of data that only has value if you have the ability to interpret it and act upon it. According to IoT Business News and IDC, 56 billion connected devices will generate 79 zettabytes of data by 2025. Nearly 30% of that data will require real-time processing. And with the cloud driving down the cost of storage, customers no longer need to decide what data to keep and what to throw away. AWS has supported customers in their ever-growing needs for high-volume data storage, having dropped the storage price per gigabit by 83% between 2008 and 2019. Moving data to the cloud enables this enormous magnitude of data to be manageable, secure, and actionable. The city of Detroit is the largest and most populous city in Michigan, with more than 670,000 residents. Detroit uses AWS to resolve traffic problems in less than 2 hours instead of 8 hours, reducing travel times by 30%. To do this, the city implemented a remote traffic management system based on MioVision Traffic Link. MioVision Traffic Link is an intelligent transportation system platform that modernizes existing traffic signal hardware, adding connectivity, video capture, and machine vision to help cities measure what's happening at an intersection and make data-driven decisions to improve traffic. Traffic Link data is transferred to AWS Cloud Infrastructure, where traffic engineers can use MioVision Traffic Insights, a web-based analytics suite, to evaluate signals based on real-time data and reduce congestion, save fuel costs, and improve safety. Traffic Link also makes managing signal infrastructure even easier, notifying traffic teams when signals are not working. Instead of waiting for citizen complaints, Traffic Link notifies the city's engineers using email or SMS, a feature that leverages Amazon SNS. Detroit Public Safety was able to integrate existing emergency vehicle tracking units with traffic lights to ensure the vehicles were given green lights. Emergency vehicle preemption has improved emergency response times by almost 20%. And this integration required no additional investment in hardware or communications because they were using technology they already had. This additional benefit was made possible because the intersections are built on open architecture. Clearly, as organizations begin to see how an effective data strategy can improve their mission outcomes, they are looking to the cloud as the right home for the data storage and analytics workloads, a concept we call a data-led migration. Data-led migrations are driven by business and mission leaders and focused on solving urgent, near-term challenges through data and analytics. Data-led migration is not just about moving the data, it is about moving the data to gain insights and value from an existing or pre-built analytic engine and using the flexible infrastructure afforded by AWS to create next-generation analytical models powered by AI and ML. This addresses specific organizational needs where the use of analytics and machine learning can be valuable, such as migrating data for health resources at hospitals during an emergency response, optimizing traffic signals, or improving vendor supply chains for defense agencies and their network of aerospace and defense manufacturers. The organizations we've talked about so far today were all looking for ways to get the power of machine learning into the hands of every developer and every data scientist, allowing the smartest people in their organization to reimagine what's possible and create innovative solutions. To achieve this, they first developed a strategy for how to actually migrate the data into AWS and create a foundation for how new data from a variety of sources would be stored in the future. This leads to the next step, the creation of a data lake. A data lake is a centralized, curated, and secured repository that stores all your data, both in its original form and prepared for analysis. A data lake enables you to break down data silos and combine different types of analytics to gain insights and guide better business decisions. However, setting up and managing data lakes today involves a lot of manual, complicated, and time-consuming tasks. Operational challenges in building a data lake lie in the fact that data ingestion and management can be difficult, and securing it all with the correct governance and access policies can be an expansive project. You want to make sure self-service analytics are possible, but how can you prepare the data for sharing and enable external integration safely and efficiently? Using AWS Lake Formation, customers are able to easily set up a secure data lake in days or weeks, a process that usually takes months. Creating a data lake with Lake Formation is as simple as defining where your data resides and what data access and security policies you want to apply. Lake Formation then collects and catalogs data from databases and object storage, moves the data into your new Amazon S3 data lake, cleans and classifies data using machine learning algorithms, and secures access to your sensitive data. Once your data is in the data lake, your users can then access a centralized catalog of data which describes available data sets and their appropriate usage. Your users leverage these data sets with their choice of analytics and machine learning services like Amazon EMR for Apache Spark, Amazon Redshift, Amazon Athena, or Amazon SageMaker. Then they can visualize it all with Amazon QuickSight. AWS has more data lakes and analytics than anywhere else, hosting tens of thousands of data lakes across industries of all types. AWS even has a data lake service specific to customers with healthcare data needs. Amazon Health Lake enables you to store, transform, and analyze health and life sciences data in the cloud at petabyte scale with out-of-the-box HIPAA eligibility. Here's a great example of how Amazon Health Lake is being used today. Founded in 1855, the Children's Hospital of Philadelphia is the first U.S. hospital devoted exclusively to pediatric care. Its main campus is in Philadelphia, and it operates several other facilities in Pennsylvania and New Jersey. CHOP is fueling new insights into pediatric diseases through the AWS-powered Gabriella Miller Kids First Data Resource Center, with 1.5 petabytes of genomic, clinical, and imaging data. To better understand how genetics impacts treatment options, health outcomes, and follow-ups, KFDRC integrates clinical data from electronic medical records and research forms using Amazon Health Lake to store over 26 billion occurrences of over 215 million unique genomic variants from 5,000 participants. Remember, the important underlying element to all of these great solutions is the data. AI and ML need to act upon data to generate insights. So before you can have a plan for AI and ML, you need to implement a data strategy. You'll need to ensure the systems you design and use can ensure the quality of your data at any scale and support all the data sources and types that your organization uses. The other thing you should know is that you don't have to start this journey alone. In fact, you probably shouldn't. You have lots of great resources out there to help you get started. First, begin to think about your data strategy in terms of your organizational mission. Follow the AWS Public Sector blog to see how organizations like yours are building upon a successful data strategy in the cloud to solve unique challenges. Second, learn how to make data a strategic asset in our no-cost ebook by clicking the link in this slide. Third, start small with AWS Quick Starts. Quick Starts are automated reference deployments built by AWS solution architects and AWS partners. Quick Starts help you deploy popular technologies on AWS according to AWS best practices. You can reduce hundreds of manual procedures to just a few steps so that you can build and start using your environment within minutes. Last, use AWS partners like DLT Solutions along the way. Partners work with our customers to design, implement, and manage cloud environments tailored to the unique needs of each organization. Well, I want to say thank you for watching, and I want to say thank you to DLT for the opportunity to be here and discuss data-led migrations. I invite you to join the discussion by following me on Twitter or LinkedIn via the links on this slide. Thanks again, and I really hope my team has the opportunity to support you and your goals sometime soon. Take care.